Hello and welcome to another Orange Coast College Mathematics video. In this video, we're going to learn how to use function notation. That is, when you're given a function in the form f of x equals some expression of x. Now, when you're given a function like f of x, now we don't have an expression here, just written f of x, it's very important to understand x is the input variable. So you'll be given some rule. This will be equal to some expression of x. And so whatever the value in here is, we're going to evaluate that function by plugging in for x, whatever we have here. It's usually easiest to see this if we just go through some examples. So let's get started. Here's our first example. Now, given the function f of x equals 3x minus 4, let's find f of 3, f of a, f of x minus 1, and f of a plus h. Now, first we begin with f of 3. So f of 3, now it's very important to understand, that's f of 3. Now, sometimes we use parentheses for multiplication, right? It's important to understand when you have a function, which is usually given by f or g, not always, but usually f or g or h, those letters. What that means is it's f of 3, not f times 3. So we're going to evaluate the function up here when x is 3. Since this says f of x equals 3x minus 4, this is basically a rule, right? It says you take the input variable x and you multiply it by 3 and then subtract 4, and that will be the function value. So when we say f of 3, we mean we take 3, multiply it by 3, and then subtract 4. So we should get 3 times our input 3, and then subtract 4. That will be 9 minus 4, which is 5. Okay. For b, it's almost simpler than that. F of a just means we look at what's the output value when the input value is a. So again, we take 3 times a and subtract 4 to give us 3a minus 4. There's nothing else to do here because we can't simplify that any further. Okay. Now c, we have f of x minus 1. So basically, we're going to see what's the value of our function when our input value is x minus 1. So we have to respect order of operations. So we take our input value of x minus 1 and multiply it by 3. But notice I'm putting parentheses around it so that x minus 1 is multiplied by 3, the whole of x minus 1. And then we subtract 4. Okay, we should simplify this. So we're going to distribute this 3, right? So 3 to the x, 3 to the negative 1. So we do, this will become 3 times x minus 3 times 1 minus 4, and this will give us 3x minus 7. Okay. For the last one, it's very similar to the previous one we just did. Again, f of a plus h, we simply replace x with a plus h. We're going to multiply a plus h by 3 and then subtract 4. And the only thing left to do now is simplify. So if we distribute the 3 to each term, we get 3a plus 3h and then minus 4. Example 2. Given the function f of x equals x squared minus 2x plus 5, find f of negative 2, f of a, and f of x minus 1. So our rule here for a, we want to find f of negative 2. So our input value is negative 2. So we take our input value, negative 2, and we square it. We subtract 2 times our input value of negative 2, and then add 5. Notice that, again, I'm respecting order of operations here. I put negative 2 in parentheses because we're squaring the whole thing, negative 2. So negative 2 squared becomes positive 4. Then we have minus 2 times negative 2. That also becomes positive 4. And then plus 5. And that gives us a result of 13, which is our output value. For b, f of a, we're really just replacing one input variable, x, with a different input variable, a. So we simply rewrite the function rule, but we replace x with a. So it becomes a squared minus 2a plus 5. For c, we're replacing our input variable of x with x minus 1. So again, we square our input, which is x minus 1. Notice I square it in parentheses there. I'm squaring the whole difference, x minus 1. Minus 2 times x minus 1 plus 5. Okay, now I have to simplify this. X minus 1 squared, that is a special product, right? It's a square of a binomial. So we square the first term, Then we take 2 times the product of the two terms. So that's 2 times x times -1, which is -2x, and then plus the last term squared, which is 1. Then we have to distribute this -2 to both terms here, so it becomes -2x. And then -2 times -1 is +2. And then plus 5. Finally, we combine like terms. There's only one x squared term. We have -2x and another -2x term that's combined to give us -4x. And then 1 plus 2 plus 5 is 8. So we get that f of x minus 1 is x squared minus 4x plus 8. Here's our final example. Given the function f of x equals 1 divided by x, or 1 over x, find f of 4, f of 0, f of x minus 1, and f of x plus h. So for a here, f of 4, we take our input variable. It's going to replace it with 4. So we evaluate the function. So we get 1 divided by 4. Since, again, f of x equals 1 over x, that's you take the input value, right? What's the rule for f here? You take the input value and you do 1 divided by the input value. So in this case, 1 divided by 4 is 1/4. Now for b, we run into a problem. You might start writing down f of 0, and you end up writing down f of 1 divided by 0. However, you cannot divide by 0. This does not give us a number. So f of 0 is what we say is it's undefined. And what that really means is that 0 is not in the domain, right? The domain for this function f of x would be all of the real numbers that I'm allowed to plug in. That when I plug in for x, 1 over x will be a number, a real number. Since 1 over 0 is not a number, right, this function is not defined at 0. So 0 is not in the domain. For c, f of x minus 1, we simply do 1 divided by the input value, which is x minus 1. So we end up with 1 divided by, or 1 over, x minus 1. For d, it's a similar story. Okay, f of x plus h will give us 1 divided by x plus h. We replace x with the new input variable. Again, we respect order of operations. We're doing 1 divided by the input value, so we should have 1 divided by x plus h. And that's it for function notation. So hopefully now you feel comfortable evaluating functions at different values. Again, if you just practice this, I'm sure you'll have it down in no time. Until next time, have fun.